Welcome to today's explainer. If you were to look at a highly magnified cutaway view of your own stomach right this very second, you wouldn't just see human cells. Nope, you'd see an entire, bustling metropolis of microscopic partners. Without the tiny, invisible microbes living in your gut, human digestion simply wouldn't work. You are, quite literally, a living ecosystem. And today, we're unpacking exactly how these ultimate biological partnerships operate behind the scenes.
Okay, here's our step-by-step roadmap for today. First up, nature's ultimate partnerships. Second, the 3 types of symbiosis. Third, we'll map out energy flow and food chains. Fourth, unlocking the nitrogen cycle. And we'll wrap up with Section 5, avoiding common exam mistakes. Let's jump in.
All right, Section 1, Nature's Ultimate Partnerships. Let's lay down the fundamentals.
So, what exactly is symbiosis? By definition, it's a close, long-term interaction between 2 different species. And I really want to emphasize that 2 different species boundary marker. It's the absolute foundation for interconnected life. It isn't just about animals happening to exist near each other. We're talking about a structural, mechanical reliance that forms over a long period of time. It's like a giant biological puzzle where the pieces actually depend on each other to stay locked together. Moving right along to Section 2, let's look at the 3 specific types of symbiosis. Check out this table. It's a perfect visual rubric for these relationships. We're using a really simple plus, minus, and zero system here to label the exact dynamics. Look at the top row, mutualism. Species A gets a plus, and species B gets a plus. Both species benefit, like the clownfish gaining a safe home and the anemone getting a good cleaning. Now in commensalism, those variables shift to a plus and a zero. One benefits, while the other is completely unaffected. Just visualize barnacles getting a free ride on the side of a massive whale. Finally, they've got parasitism, a plus and a strict minus. One benefits at the precise expense of the other, like intestinal worms draining nutrients directly from that whale's gut. Definitely lock these plus, minus, and zero labels into your memory. Okay, Section 3. Let's shift gears from how species partner up to the actual mechanics of energy flow and food chains. Look at this step-by-step flowchart. Every single ecosystem flowchart on Earth begins right here at Step 1 with our massive initial energy source, the sun. Follow the arrow to Step 2, producers. Through the specific biological mechanism of photosynthesis, plants convert that incoming sunlight directly into chemical energy. Finally, follow the flow to Step 3, where that energy moves up the chain to consumers. This perfectly bridges that macro event of an animal eating a plant with the invisible, underlying microflow of chemical energy. But here is where we hit a massive mechanical limitation in biology. Look at this number, 10%. That single specific number represents how astonishingly inefficient energy transfer actually is between these steps. Only about 10% of the energy successfully transfers from a producer to a consumer. So you're probably wondering, where on earth does the rest of it go? Well, this donut chart brilliantly illustrates why. See that massive 90% slice? That represents energy literally bleeding off into the environment as lost heat. It just escapes the system. Compare that massive loss to the tiny 10% sliver of power that actually moves forward. It takes an enormous foundational amount of energy just to sustain the very next link in the food chain. Kind of crazy, right? All right, let's zoom in even further, from macro energy systems down to the microscopic chemical level. For Section 4, unlocking the nitrogen cycle. Let's track this invisible chemical sequence together step by step. Up top, in Step 1, atmospheric nitrogen, label here with the chemical variable N2, is just floating in the air. Following the directional arrows down to Step 2, that N2 enters the soil. But here is the absolutely crucial microscopic mechanism happening in Step 3. Tiny, invisible bacteria act as mechanical processors, physically converting that N2 into usable nitrates, labeled here as NO3-. Without this exact chemical transition facilitated by those microscopic bacteria, plants simply couldn't grow, and the entire food chain would collapse. It's a real game changer.
Finally, Section 5. Let's make sure you can actually apply this and avoid some common exam mistakes.
A massive trap people fall into is confusing mutualism on the left with commensalism on the right. Look at the text comparison here. Remember our variables from earlier? Mutualism requires a dual benefit. Both species get a plus. Commensalism means one species benefits and the other gets a zero. It's completely unaffected. If you lack that mutual two-way benefit, it is for sure not mutualism. So, to pull this all together and totally ace those exams, just follow this checklist. First, clearly define all three symbiotic relationships using those exact plus, minus, and zero variables. Second, have your real-world examples ready for each type. Third, remember the stark inefficiency of energy flow, that strict 10% rule we talked about. And finally, map out the nitrogen cycle by practicing those exact chemical transitions, specifically from atmospheric N2 to usable NO3-.
As we wrap up this explainer, I want you to take a second and literally just look down at your own hands. Consider your own biological footprint. What unseen systemic interactions, what microscopic chemical cycles are actively running inside your body right this very second, making your life possible today? Nature's ultimate partnerships are happening all around you, and more importantly, right inside of you. Keep exploring and keep questioning the amazing systems that sustain us.